Welcome to qnawire.
All right, we've got the following molecule. So we've got an ethyl, an isopropyl, and a methyl. And we need to know in the lowest energy conformation how many of these alkyl substituents will be equatorial. So the easiest way to see this is going to be to draw the chair conformation of this and then draw the chair flip. So we'll draw a chair like this. And let's start drawing in substituents arbitrarily because we're going to draw the chair flip anyway. So I'll just pick this methyl to be axial in the original. All right, so let's call this carbon 1, 2, 3, 4, 5, 6. And we're saying 1 is axial. So that's a methyl, and that's hydrogen. And we'll go number these 2, 3, 4, 5, 6. Okay, so we know on carbon 4 we have an isopropyl, and we know that it's on the opposite side of the ring as the methyl. So let's just draw these two substituents in. And then if it's on the opposite side of the ring as the methyl, meaning the methyl is up here, but down here, then the isopropyl has got to be the lower of these two bonds. Right, so this will be the isopropyl, which I write IPR, and this will be the hydrogen. Okay, and on carbon 6, we've got our ethyl, and we know it is below the ring, so it's the lower of the two on carbon 6, so there's the axial substituent and the equatorial substituent, and we said ethyl should be the lower of the two. So we'll pick the axial and down substituent. And this then would be a hydrogen. Okay, so this is one ring chair conformer, but we know that it's an equilibrium with a ring flip. Now when I do a ring flip, I call this carbon 1, and then this also becomes carbon 1. Right, so now I've got axial down, equatorial, methyl as the higher of the two. On carbon 4, across the ring, axial is up, equatorial is down. I know that isopropyl is the lower of the two, so it should be equatorial this time. And on carbon 6, we've got axial up, equatorial down, and ethyl should be the lower of the two. Great. Okay. So lowest energy conformation. We're comparing this one to this one. Well, look, on the right-hand side, every single alkyl substituent is equatorial. On the left-hand side, every single alkyl substituent is axial. We know that axial is far less energetically favored than equatorial for any alkyl substituent. So if all of the alkyl substituents are axial, that's not good. That's a very high energy conformation. The low energy conformation will be the one in which all of the alkyl substituents are equatorial. So to answer the question, in the lowest energy conformation of the compound below, how many alkyl substituents are equatorial? All three of them. There's 3 of them, and they're all equatorial.